everything works as expected. Here you can see the button, let's click on it, and the message box Customer Edit comes up. Great, let's close this again. In the next clip, I want to show you a bit more how this SAML document and this code behind file are actually glued together. In this demonstration, I will ensure that you understand how files are generated behind the scenes in a WPF project. Let's switch to Visual Studio. Here I've opened the main window SAML file of our WPF project. Before we look at the generated files, I want to show you how you can access this button instance from the code behind file. To do this, you give this button a name with the xName attribute. Let's call it btn add customer. Now let's go to the Solution Explorer and let's open the code behind file of the main window. Here in the Click Event Handler, I don't want to show a message box. Instead, let's change the content of the button. Now you can access the button with a name that you gave it in SAML. Let's set its content property here to Customer Edit. Now let's run the application and let's see this in action. Let's click here on the button and now you see the adjusted text. Great, now let's close this window again. Now when you look here at this main window class, you can see two things. First, there is this btn add customer field of type button that is not defined here in this file. Next, there is this call of the initialize component method in the constructor, and that initialize component method is also not defined in the main window class in this file here. But actually, the C# compiler needs this btn add customer field and also this initialize component method to compile this main window class. So, somewhere in the project, these members must be defined. When you look at the class definition, you can see it has the partial keyword. This means that the class definition can be split across several files. And this is what is actually the case in this project. Another C# file is generated behind the scenes from the SAML document. So when you go to the Solution Explorer and when you look at the properties of this C# file, let's do this, you can see the build action here is C# compiler. The C# compiler processes that C# file. When you look at the properties of the SAML file, you can see the build action is page. This means that behind the scenes, a SAML processor is processing the SAML document when you build the project, even when you just type code in Visual Studio. So, from that SAML document, C# code is generated in addition. When you open the SAML document, you can see on the root element the xClass attribute, which is set here to Wired Brain Coffee Customers App main window. This is actually the class name that is used for the generated file. And it is exactly the class name that you find here in the code behind file. We have here the namespace Wired Brain Coffee Customers App and the class main window. Now let's look at the generated code. So let's right-click here the initialize component method and let's select Go to Definition. Now you can see a main window GICS file opened up. Let's go again to the Solution Explorer to see where this file is actually located. First, I click here on this little button from the Solution Explorer's toolbar to show all the files. Next, I click on this button to sync the active document, which is this generated file. Let's click on it, and now you can see you are here in the Object Debug folder of the project, and here is this main window GICS file that gets generated from the SAML document. When I scroll up in this file, you can see it has the namespace Wired Brain Coffee Customers App and the class is main window. It is also a partial class definition here, which means this file and the code behind file define together the main window class. Now I want to show you something. Let's grab the SAML document and let's split it here to the left side. Now on the root element of this document, let's change here on the X-class attribute main window to main win. Now I save this, and you can see that the class name in the generated file also changed to main win. This means that this generated partial class does not match anymore the partial class of the code behind file. So when you look at the code behind file, you see initialized component is not found anymore, and also the btn add customer field is not found anymore, because we have here a partial class main window. Now let's go again to the generated file, and let's change in the SAML document the class name again to main window, and let's save this. Now you see it changed here again in the generated file to main window, and now when you look at the code behind file, everything is fine again. Because in this generated file, you can see actually here the field for the button that gets generated from the SAML document. So here is this btn add customer field, which is in this partial main window class, which means you can just access it from the code behind file, because this is actually the same main window class, just in a different file with a partial class definition. Then when you look at the rest of the code, you see here this initialized component method, which is responsible to load the elements defined in the SAML document into the window object. And then you see down here a connect method that initializes the btn add customer field with a button from SAML, and here also the event handler for the click event is installed. Now let's go again to the Solution Explorer and let's sync again with the active document. Beside the GICS file, you see here also a GCS file. Both contain pretty much the same content, as they are actually like two different versions of the same file. Then you see here a BAML document, which is a binary representation of the SAML document that is compiled into your assembly. This is done to save a bit of space, as binary is more compact than SAML. You can see here also a generated file for the application object. So when you actually look at the app SAML file, you can see it has also here an X-class attribute. When you right-click this file and when you look at the properties, you can see the build action here is not page, it is application definition. That build action creates actually the main method in the generated file. So let's also look at this one. Let's open here the app.gics file and let's scroll down in this file. And you can see here at the bottom the generated main method that creates and runs the app object. Alright, so far to the generated files behind the scenes. When you work with WPF, you just use the SAML document and the code behind file. And in simple words, the X-class attribute is the connection from your SAML document to the code behind file. Now let's wrap up what you have learned in this module. You learned in this module that the Windows Presentation Foundation is a user interface framework that is part of .NET. You can use WPF to build desktop applications for Windows. Visual Studio itself is actually a WPF application. One of the key features of WPF is that you define user interfaces with the Extensible Application Markup Language, or short SAML. You learned in this module that the main window of a WPF application consists of multiple files. The user interface is defined in a main window SAML file. Then there is a corresponding C# file that is called main window SAML.cs. This file is also known as code behind, and it is the file in which you implement the logic for the user interface. You also learned in the last clip that from the SAML file, additional C# files are generated behind the scenes in the Object Debug folder. Now, one of the most important things to understand when you get started with WPF is how SAML actually works. In the next module, you will learn more about this markup language that is used in WPF. I will show you how to instantiate objects in SAML, and you will learn how to set simple and complex properties on these objects. In the previous module, you added a button like this to the main window of the customer's application. Button is an element. As SAML is based on XML, you need to close elements correctly. So here, you can add a closing element to get valid SAML. But as there is nothing between the opening element and the closing element, you can omit the closing element and you can close the element directly with a slash. This is now a so-called self-closing element. In SAML, an element is mapped to a class. In this case, an instance of the button class is created. As you can see, on the button element, the content attribute is set. The attribute has the value @customer. An attribute in SAML is mapped to a property. This means that in this case, the content property of the created button instance is set to @customer. But there are also other attributes that you can set, like for example the click attribute. In this case, click is like content an attribute, but it is not mapped to a property. Instead, it is mapped to an event. Or to be more concrete, the click attribute is mapped to the click event of the button. The specified event handler button_click needs to be defined in the code behind file in C#. Now, this is a really important slide that you should memorize. Elements in SAML are mapped to classes and attributes are mapped to properties or events. This is quite obvious when you look at the equivalent C# code for this SAML snippet. In C#, you create a button instance and you set the content property, and then you attach an event handler to the click event. So this C# snippet makes it very clear that SAML elements are mapped to classes and that SAML attributes are mapped to properties or events. Now, in this demonstration, let's explore the button in the customer's app that we have created in the previous module. Let's switch to Visual Studio. Here I've opened the main window SAML file of the customer's app. On the button element, we set the properties content, horizontal alignment, vertical alignment, and margin. We have also defined an event handler for the click event. Then we have here a special attribute, the xName attribute, that is used to access the button with this name from the code behind file. So this is an exception where an attribute is not mapped to a property or an event. This is a special SAML attribute. Now when you look down here, you can see that we have created a closing element, but there is nothing between the opening element and the closing element. This means you can actually remove this closing element and you can close the button element directly with a slash. Alright, so far we set properties on this button with the so-called attribute syntax. We use attributes. In the next clip, you will learn more about another syntax which is called property element syntax. In this demonstration you will learn how to set properties in SAML with the property element syntax. This syntax allows you to assign a complex object to a property. Let's switch to Visual Studio. Here I've opened the main window SAML file of our WPF project. On this button element here, you set here the content property by using the so-called